Dottori, welcome to this video where I'll be talking about the Sane C++ libraries. So this video will be just a very quick introduction to the project. I will be showing the GitHub repository, a little bit about how the documentation website is structured, how the directories are structured, and the building the test project and how to work in Xcode, VSCode, and Visual Studio on macOS and Windows. So what is this project? This project is a set of C++ platform abstraction libraries for macOS and Windows that is, it's printing some principles before even listing what is included. So I guess they should be important. And let's have a look. There is a blog post that goes a little bit more in detail on how I got there and what I would like to be doing. But so far, you can give it a read if you like. And there is a documentation website which we can look at. And it's again printing the principles at the very top. So what are these principles? The first one is the fast compile times. Why do we talk about fast compile times? Why do I talk about fast compile times? So my experience with C++ is that projects have this tendency to just grow with exponentially larger compile time, and I would like to create something that goes in the opposite direction. It's perfectly possible creating C++ libraries that are able to do a lot of things while still being extremely fast to compile. And so that's where we want to go. So first item is this one. The second one is bloat free. So for some definition of bloat, which can mean, I don't know, executable size, which can mean not needing to have way too complicated build process or many features that are simply not needed in a majority of cases. We would like to avoid all this kind of stuff, so providing a good set of things that are that are important, that are important enough to be included, but still useful without covering 100% of use cases, but a good enough subset. We would like to, I would like to write a library that is simple to read, and I'm putting some effort into that. So writing code that does not use obscure, I don't know, C++ templates or other types of machinery like that. Actually, a little bit of that code exists somewhere, but it's kind of partitioned away from the main library just because it was more like of a test. But this is important. If something is way too complex for, I don't know, someone that is a little bit more than a junior C++ programmer that has just started, if someone like this hypothetical junior guy cannot comprehend what's going on, then it's not a good code that should fit into the library. The library should also be easy to integrate, so no build system is required. You can just add a CPP file and start including the headers, and things should just be working fine. You will see there is an integrated, very primitive for now build system, but it's not required to use. It's required if you want to be building the test project, but it's not required if you just want to be a user of the library. So the other two items are explaining, are going in the detail of what's very high level, what's allowed and not allowed to be used in the libraries. So the C++ standard library is not allowed for reasons that I would like not to be discussing right now, and also exceptions and runtime type identification. Let me know if you are interested in knowing why I don't want to use this these items, these features in the project, and I can explain my perspective, which is my perspective. And we would like to avoid any kind of third-party dependencies, again, to keep mainly the easy to integrate bullet point still valid, and so preferring to use OS API where possible. On macOS and Windows, this is quite easy to do because there is a lot of functionality provided by the OS itself. I guess when going on Linux land, this will become not so trivial, but we'll see what we will be able to achieve. You can give it a read at the motivations, which is, just having fun more or less and reinventing the wheel. And you can have a look at the status of the libraries. I kind of partitioned them into like first status sets, which is draft. So, the library is just, I know what I would like to be building, but it's like incomplete and it's a work in progress, or at the very best, a proof of concept and so on. An MVP is like, okay, some minimum viable product or minimum set of features has been implemented. You can try to use it. Usable, so green means, yeah, green light. This library looks like it's good enough to be used, and it's very rarely achieved by any of the libraries at this point. And complete is something that I hope at someday I will be able to achieve for at least some of the libraries, where it will be like, okay, this library will not receive any new feature because all the planned features have been implemented, and that this is fine. We can have a look at the detail of what each library is doing, but before doing that, I would like to just briefly show how the documentation website is done. So there's this front page, and then there is the list of libraries. Each library has its own dedicated page with the status, the description, the roadmap, and some code examples, extracts from the detailed documentation, and considerations and notes on how to use it. So if you would like to know something about any of them, I suggest this is your first stop, probably, before even trying to ask some question. Of course, you can ask any question, and hopefully I can answer, but many answers are already in the documentation. And this is a Doxygen generated documentation, so every class has been documented with all the methods. There may not be excellent documentation in every possible method, but it can be improved. So if you find something that really doesn't make much sense or doesn't add more from a documentation standpoint, feel free to let me know. Now, I would like to show a little bit about the organization of the directories in the repository. So this is the cloned repository. There is a VSCode folder, .vscode folder, that has all of the launch and tasks and settings. So all the required files to work under VSCode, at least on Mac, with the library. The supporting Windows in VSCode out of the box for the tasks is something that I will definitely be doing in the very next future. So probably, maybe if you see this video a little bit later, things may not be one-to-one with what I'm showing here, but you can probably extrapolate what's missing. You will be able to extrapolate what's missing. There is this bindings subdirectory, which is where I plan to add bindings for other languages. I would like to create C bindings for some of the libraries, especially like the async library. But so far there is only a CPP folder with a Unity build file that is just including all of the CPP files of the entire library. So this is your single file you can add to your build system, such that you can link the entire library. And the headers are just in libraries, name of the library, you know, the first .h file that you will be finding. Sometimes there can be multiple, but you know, it's pretty clear. Everything that is in this first level of subdirectory, it's a public header, and you know, private headers are in the internal subdirectory, which exists in the majority of the folders belonging to each sublibrary. And there is, you know, every library has a tests subfolder with the tests for that library. It's kind of pointless, probably repeating that, but it's there. We have a documentation folder with all of the markdown that has been used to generate the documentation website. And so everything you see in the documentation website has been generated from this MD files. There is no build script here for building the documentation. It's in another repo. I need to clean it up, and probably at some point it will be merged here, or placed into some other repository. So the libraries has all of the libraries, and libraries extra contains some of the libraries which are not let's say are not able to fulfill all of the rules, or they are not obeying to all the rules placed by the principals. For example, there is an automatic reflection library that is using way too complicated C++ meta programming, you know, type of techniques, and it doesn't fit the definition of simple readable code. So it will never probably be included in the libraries, but it's there as a test. It will just be there for, you know, until I decide to delete it probably, or to morph it into something else. And there is, for example, another library that is a re-implementation of the serialization library, so something that is really not supported. There is a support folder that has the build bootstrap for the build system. This would require a dedicated video to explain how it works, but for now, that's what the build system is using to bootstrap itself and start generating projects. There is a set of debug visualizers for LLDB and MSVC debugger, so the NatVist and the Python LLDB debug visualizer, such that, for example, when you have containers, they will be showing the content of the container instead of some garbage pointer to, you know, whatever data structure it's in the vector, and so on. The tests subdirectory contains the entry point for the tests. So far, there is a single test suite which is called SC test and contains its running tests for the entire library. At some point, probably we will have multiple test suites. In the root, you can find, of course, the CLang format file, because all the files in the project are formatted with CLang format. And I guess I don't know if it's possible, but add some repository hooks in GitHub to prevent, you know, anyone from sending something that is not formatted properly. There's the README, of course, and this is the bootstrap for the test project. So the SC build CPP file is a CPP file that it's built into an executable. We will see, and it's generating the test projects. Let's try to do it. So, where have I gone? Just in the wrong directory. Let's do like this. Terminal again. So sc build command. So this command file, it's calling the support build sh with a bunch of parameters, and let's try to run it. And this is building an executable called sc build, and this sc build executable, so on Windows this will be scbuild.exe. It's run and it generates the solution file for Visual Studio and Xcode. So very, you know, I don't want to say simple, nothing is simple, but straightforward. This is how you build the test projects, and let's try to open some of them. So they are in this underscore build directory, in the projects, into the Xcode, and we can open this one. Okay. So we can see that the build system has been adding all of the libraries and the tests. So we can compile it and we can run. Let's see how much time does it take this to even compile. 2.3 seconds. So this is not a Unity build. So this is compiling single files. And it's wasting some time, you know, even if every file takes 0.1 second. This is an M1 Pro MacBook, so definitely not a slow computer, but you know, it's not the fastest thing you can buy. So that's pretty solid performance, I would say. If you take the Unity build file, I think this is lower than 2.3 seconds, but the point is that the library is quite fast to compile. We can run the tests. If I run the tests, they just print things. Hopefully everything succeeds, and yes, it succeeded. And you can, of course, in Xcode, the project is ready to be stepped, so you can you can go in, I don't know, one of the tests. Let's pick one test. I don't know, container test. No, vector test. Yeah, we have a vector test. And you can, I don't know, yeah, place a breakpoint here, and we are debugging. We can try to do the same under VS Code. Hopefully it will work. So let's try to see. In VS Code under macOS, I've set up this debug sc test clang, which should be calling the Xcode build, and then the LLDB. Yes, the LLDB will be attaching to the executable, and it will run the test. So let's try to see if this should even be linking the debug visualizer. So if I go in the debug visualizer tests, which is a very stupid file where I'm just creating bunch of vectors and small vectors and strings with UTF characters, I should be able to, when stepping into it, I should be able to see what's inside of each one of these items. So let's see if it works. Yeah, so the string, this is a UTF-8 string. It's shown correctly with this emoji, even this UTF-16, and so on. I'm doing some slicing. This is a small vector. It says, yeah, vector and capacity. It shows all of the items. So debug visualizers, they look pretty much working out of the box, and this is due to the SC build system, which is injecting the debug visualizers, which exists in the support subdirectory, directly into the project file. So this is good. Now let's try to do the same under Windows, and to make sure we are not using anything generated from here, I will remove the build subdirectory. So build subdirectory is removed. Now let's try here to regenerate the project. Instead of a command file, we have a batch file. Of course, everything here is a little bit slower because I'm clearly on a VM. It's but it's nevertheless, this is good. We have to open the project. I don't, where is the project? So Mac, is this, yeah, developer. Of course, we have a project and we have an SC and there is a build project and we have a Visual Studio and sctest.sln. Okay, here we are. The SC test can be built, and by building that, which is again slower than macOS side, we are able to run and step into the project just like what I've shown before. So I can place a breakpoint into the, I don't know, async test. Oh, I compiled it for x64. This is an ARM machine, so we can even compile it for ARM64. Of course, the test it's failing because when I wake up the virtual machine the first time, things are not working properly. I don't know why, if it's a problem of Windows or the virtual machine, but that's what it is. So you can step through the unit test suite and I don't know, have some insight of what's going on. So if I rerun the test, of course, now it runs fine because the virtual machine is not waking up from sleep and everything is fine. So you have this ARM64, you have debug and release configuration. I even added the debug with CLang configuration under Visual Studio if you would like to use CLang under Visual Studio. So this is pretty nice. Now let's go back at, oh, I almost finished the bullet point list that I prepared for this video. So I think for now this is enough. Of course, it would be useful describing what each specific library is doing, but I think this belongs to another video, and I would like to say bye to everyone and have fun.